On M5, we're going to simplify expressions involving rational exponents. And it's going to get kind of tricky in some parts. So what I try to do is give you some notes whenever you are going to have an even root. If you have an even root, then your problem is going to get a little bit more complicated than if you just have an odd root. So kind of bear with me on explaining this. If you have an even root, it really doesn't matter what this number is, but once we do the problem and our answer exponent ends up being even, I know you have no idea what I'm talking about right now, but if it ends up being even, then you don't have to stress about anything. But if we start with an even root, and we end up with an odd exponent, that's when we have to pause, and whatever that part is that is odd, we are going to put it in absolute value brackets. The reason for that is whenever we have an even amount of exponents, we don't know whether that base was positive or negative. It could have been either one. So whenever our answer is odd and our answer, we still don't know if it's positive or negative, we're going to put absolute values around it to be able to know, to make sure that we're able to do it. All right, so on this, what does this mean? Well, we have the cube root of x to the third. X to the third means I have 3 x's, right? So if I'm taking the cube root, I'm looking for 3 of a kind. Do I have 3 of a kind inside the radical? Yes, I do. What do I have 3 of a kind of? Of x's. So my answer is going to be x. And since this is odd, I'm not going to stress, and my answer is just going to be x. Here's the trick. If this is 3, this is 3, all you do is divide. So we divide, and 3 over 3 is 1. And so since this is odd, my answer is just x to the 1, or just x. But here, whenever there's not an exponent, there's not a root, it's understood to be 2. 2 is an even number. 2 is bad. So we're going to have to think about this whenever we get finished, okay? So we're not going to worry about it until the very end, until I think that I'm close to having my answer. So I have the square root of x to the third. Well, x to the third means x times x times x. Since my root is 2, I'm looking for 2 of a kind. Do I have 2 of a kind inside the square root? Yes, I do. I have 1 pair of x's inside the square root. So because I have a pair of x's, that x is going to go to the outside. But this x didn't have 1 to go to the outside. So it has to stay on the inside. Okay? So I've done the problem. Now I have to make sure I pause and see this. So on here, my outside exponent, I had one group of x squared, or one group of x's. And so that red 1 right there is an odd number. So this 2 is even, this 1 is odd. So since I have an odd answer, that needs to go inside absolute value brackets. The fourth root of 625 is 5. If I have 5 x's inside here, I have x times x times x times x times x. I'm looking for 4 of a kind. I have one group of 4 with 4 left over. Since this is even and this is odd, we have to put absolute value signs in that. This is odd, so this is good. So we don't have to worry about anything besides just doing the cube root of 512. That's 558. And what you could do, show you a little different way of doing that. So there's your, I told you to divide earlier. So here's my division. Let's clean that up. 3 goes into 19 6 times with 1 left over, right? Well, since this doesn't have any fractions, it's going to go on the outside, but that 1 that's left is going to go on the inside. I forgot my 6. So this 6 is this 6. This x is this 1 right here. And I'm going to try to change colors, but I didn't do it. Okay. Let's go on. This is odd, so our answer is going to be negative because there's a negative on the inside. And 5 over 5 is 1, so our answer is going to be negative x. This is 6 over 3. This is 18 over 3. That's 2. That's 6. Since our 3 is odd, it doesn't matter. 4 over 2. 18 over 2. That's 2, and that's 9. Since this is even, and this is odd, we have to put absolute value signs around the y. We don't have to do it around the x because it has a 2 and 2 is even. 2 over 2, 8 over 2, 2 over 2 is 6, which is even. 4 over 2 is, 8 over 2 is 4, which is even. Since they're both even, we do not have to have absolute value signs. $11 over 4 goes 3, but I have some left over. How many do we have leftovers? 3. And since 4 is even, this 3 has to go inside square root, or absolute value. So the cube root of 24, honestly, I don't know. Okay, I'm going to have to go on a little side note here. And I don't have enough paper. Okay, side note. We have 24. We have 4 and we have 6. We have 2, which is done. We have 2, which is done. We have 2, which is done. We have 3, which is done. And I'm taking the cube root. If I'm taking the cube root, I'm looking for 3 of a kind. Do I have 3 of a kind that multiplies to get 24? And I do have a group of 3. Now, this 3 didn't have 3 to go with it, but the 2 did. So what happens is the 2 comes on the outside, but the 3 has to stay on the inside. And then 3 over 3 is 1. 6 over 3 is 2. Since our root is odd, it doesn't matter, so that's going to be our answer. Square root of 289 is 17. X to the 4 over 2. Y to the 2 over 2. 4 over 2 is 2. 2 over 2 is 1. Since it's 1, it's going to be an absolute value because that was even. So the 4th root is 625. 2 over 4. 8 over 4. The fourth root of 625 is 5. I don't have a group of 4 because I only have 2. So that's going to go back inside. And x and y is going to be squared. That's it.